Thank you, Mr. Pereira. I appreciate it. So we're basically starting here. For the guys who are not here, we are solving the next example which we had during the interval. Okay, so where I started was we initially draw our TS and our pH diagram. Now, obviously, this is important. And what I was mentioning is that a equation could either give you pressure or temperature. And you must be aware that your saturation pressure, I'll write it here, saturation pressure and temperature is interchangeable, right? Is interchangeable. So, okay. So in this case, they give us minus 20. Silas did ask, the textbook is minus 12. We can do exactly the same thing. I can play around with pressures. I can play around with different, you can get a question just like this with different parameters, basically. It's all about the application of doing this, right? So if I look at minus 20, my HFHG is 238.48. So this is at T1 is at minus 20 degrees and my H1 is 238.48. Did I say that correctly? 43, sorry. We all get that, guys. It's important for you to understand how to get the values of the table. And then S1, the reason why I'm choosing S1 because we're aware that we have an isentropic compression. Obviously, this must be a straight line as well. And my S1 value is the vapor value, which is SG, is 0.94575. 94575. Make sure you write your units. Are we all comfortable with this? So what I'm saying to you is that we can either get two temperatures or two pressures. What I want to test you now on, can you please find me what is the saturation temperature of 0.8 MPa? Can someone give it to me? What is the corresponding saturation temperature in degrees? And someone tell me what is the corresponding saturation temperature pressure of minus 20? I'm going to give you guys 2-3 minutes to solve this. This is very important, very, very important, which I'm bringing up here. Silas, do you have an idea? Look on the tables. 31.31. That's for the pressure. Let's see Prof. Abdul there. What's it? That's for the pressure, no? What's it? 800. Beautiful. Exactly. This is 31.31. And look at our saturation pressure of what is minus 20 saturation pressure. What's this in terms of pressure? Let's see. Yes, that's correct. What is my P1? I'm deliberately showing you this so that you're aware. You shouldn't be stuck when you see those things. Come on, guys. But also,
sir.
Yes, yeah.
Are you asking for the corresponding saturation pressure for minus 20 degrees Celsius?
Yes, boss. That's correct. 132.82. You got it. Okay. Yes, that's correct. Now, I'm trying to talk about something here which is very important for you to understand. Let me try to explain. Remember why I asked you, why is the refrigerant? I know I'm digressing from the example. So in the evaporator, right? What this is telling you, the refrigerant is at minus 20 degrees. So I asked you, why is it lower? Like, why is it so low? Why is it low? Why is it so low? And the reason is because if you're going to have food, I think Mr. Mataso, he likes fish. I think he likes tilapia. I don't know what fish he eats. No, it's a fish there, no? This fish is coming at a specific temperature, maybe. Let's say 10 degrees. And obviously, we know heat travels from hot to cold. So therefore, we need the temperature to be low of the refrigerant for two reasons. The first one is to absorb the heat of the fish, and also we want a low saturation temperature so it can boil. It can boil at during the atmosphere. Is it clear to everyone? I don't know. I'm just trying to include lessons in between. I hope that makes sense. You know, I didn't touch on this last year, obviously. Yeah, 133 is fine. That's perfectly fine.
Sir, you mean that so that the evaporation is effective?
Yes, yes, Chief. That's the idea. And for instance, yeah, and obviously we will touch on more. I think I'm trying to make it a bit more practical. So when you're looking at these pressures and temperatures, so when you're measuring your parameters, Silas, what you want to do is take out your textbook and see how things work out. And you can see if you can look at the pressures here, this is slightly above atmosphere, right? And this is okay, 800. But anyway, so let's do the next step. So we know that S1 equals S2, and therefore now it's at a pressure of 0.8 MPa. So we know that P2 and S2, this is 0.8, and we need this is 0.94574 kilojoules per kilogram, and now we need to find our H2. Therefore, we do the same thing as a previous example. We have to go to our table and interpolate. I'm deliberately doing this process so that I'm doing it over and over, so you can get a good good practice now. Very important. Some students have picked up, didn't even know the process. It's isentropic. You cannot lose marks in this chapter. So you're going to go to table A13 again, go find the corresponding pressure, and I wanted you guys to interpolate for me. And I'm going to just snip the table for you again. Obviously, we are chief and second engineers, and we have a bit of experience, and therefore we have nice calculators to actually do that for us. 275.75. I'm not sure that is correct. Someone needs to confirm. Yeah, but that is definitely correct. That's the right value. But can everyone just do it quickly? Fantastic, guys. Fantastic. I think I'm gonna pause after this. We can adjourn our lecture. Don't wanna kill you guys, and then you guys have your, and I'll meet you guys on Friday. Friday we can finish refrigeration and start on heat transfer. Yeah. Anyway. Do we all get H2? And H3 will be equal to H4, and it's the same as the previous it's approximately the same. It's 95.48 kilojoules per kilogram. Maybe we have enough time. I don't know. We'll see. Students, are there any questions? Are you happy with this? Yeah, thank you. It should really be fantastic. Great. What am I looking at now? Oh yeah, I was just checking another textbook which I wanna yeah, okay, it's fine. Cool. So the question in this case, they wanted the COP and the part and your compressor work, and you have a cooling load here. So remember they're giving you QL, and remember QL equals H1 minus H4. This is the evaporator, right? What this means, it's the amount of energy or thermal energy the fridge is absorbing, right? This is, if you look at your reefer over here, all the products inside here. I don't know, Mr. Brio likes grapes. I think this is grapes here, no? I don't know what they're storing in these containers. And in essence, 150 kilowatts is being absorbed. So it's 150 kilowatts. We need our mass flow rate to solve our other problems, and we have H1. And what is H1? 238.45 minus H4 of 94.48. And we can get our mass flow. Can someone just give me that mass flow? So this is a mass flow rate circulating within the refrigerant system. Okay, someone saying something there. Yeah, fantastic. So it's 1,0493. Students, I hope we're all getting this. It's very important. Right? Mark allocation. Just quickly give it to you. Are we talking 1, 2, 3, 4, maybe 5, 6? Obviously, this is 7, 8 marks already. You cannot not kill the session. So once you have a mass flow, remember they require the COP and the 1-hour compressor work, right? So COP, if you don't have, obviously we know that it's QL over Q work compressor. Remember this is the in and out. This is just going to be we can do H1 minus H4, and we can do H2 minus H1. Remember over here, the reason why we can do this is because the mass flow rate of the system remains constant. So we can find our COP like that, or we can find it by finding all the individual loads, obviously. So let's find out our work here. So our mass flow is going to be H2 minus H1, and let's find this. So this is 1,0493. What is my H2? H2 is going to be 275.75 minus H1, and our H1 was 238.45. So once again, within the reefer, you need some kind of work coming in. It's a reverse heat engine, and this box is responsible for the pressure difference to circulate the refrigerant. The compressor is responsible for that. So let me get my work done with the compressor. All right. Okay. So let me see. So I think only Ernest is 39.15. Is that correct? I hope it's correct. Yep. That is the answer. So what it means, we need a compressor or compressors of that size. Massive. I don't even think a compressor is rated like that. In fact, the motor must have that power. Obviously, for us to find the COP, we could have done this, but we can just say QL over WC. We have QL, that's 1 kilowatts. And over here, we have 159.15, and let's get our next one. So let's get our COP, 3,83. It's always greater than 1, right? Fantastic. Okay. Now I want to touch on, I think, okay, is there any questions before I move on? Any questions, students? Okay, I just want to do something. So I think what I'm gonna, yeah, we're gonna have to continue on Friday. I don't wanna, you know, yeah, they have to catch up anyway. But we'll start an actual. But I just want to show you something. Something very important, the factors affecting the COP. Okay, so we've done this. This is the actual, and I just want to, so I'm glad there's no, if there's any questions, there's no, it's straightforward, fantastic. I'm quite pleased then. I'm just getting this here. Okay, I'm just looking for, I'm getting what I want. Okay, let's just quickly see. It's all good, sir. Fantastic. Okay. Yeah. Okay. I think what's good for now. Let's park it here. And continue on Friday. So Friday we will the half of the first lectures we will finish up refrigeration. Refrigeration is not a big section. I'm not really expanding upon it. Also in interest of time. And then the other half you do heat transfer. Start on heat transfer, then obviously that's how we're gonna basically get done. I'm hoping we can. Oh, this is not kilowatts here. Sorry, this is just remove this here. Okay, so yeah, it's fine, guys. Thank you for those who attended. We will meet again on Friday, and we will start on actual cycles. And like I said, the other half you start on heat transfer. It's a very easy section. All the sections from now, it's fairly easy. Air compressors can trick out someone, but with air compressors, I think I'm just gonna keep it maybe single stage. We'll get to that. But otherwise, guys, good luck for your nav arc. Make sure you go over these 2 examples. Very, very important. It's gonna come in your second test soon. And yeah, so let me just finish up the mark allocation here while I'm here. And this is 2 marks here and another 2 marks here. Yeah, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 marks, right? So this is an ideal cycle. And when you get to the actual one, you'll see. There definitely will be more marks because you will have to work on a few extra things. So, okay, guys, so we'll start on actual next week, and all the best for the rest of the day. And see you tomorrow. Cheers.